All right, then we can go ahead and get started. People may keep trickling in, that's okay. So I'm the first talk on the last day after lunch, so thank you for choosing my talk to take your nap in. This is put an agent inside your app in 10 minutes or less with the GitHub Copilot SDK. That might be the longest title I've ever done for a presentation, fun fact. I'm Daniel Ward. Really quick, this QR code, if you are so inclined, will take you to a blog post page I have up where you can download the slides. I like to do this for my presentations because I feel like I always notice people frantically taking notes or taking a picture of the slide before I go to the next one. And please feel free to do that still. I just don't want people to have FOMO. This will also be on the last slide of the presentation, so don't feel like you're going to miss something. You can still get the slides here. So, real quick about me, I'm a staff engineer, I'm a software developer and a consultant at a company called Lean Techniques, based out of Des Moines, Iowa. I actually live in San Antonio, Texas, so I work remotely. I'm a Microsoft MVP in .NET. I'm the co-organizer of San Antonio and Austin.NET user groups, so if you ever find yourself in our neck of the woods, come check us out. And you can find me online at all these places. Dan in a Can is my website. That's where the slides are as well. I'll have a QR code for my LinkedIn on the end of this presentation too. So, okay. General structure of this presentation is kind of going to be in two broad parts: foundation and application. They're kind of what they sound like. Foundation is going to be more basic, foundational stuff. It's like, what is the SDK? What do I mean when I say put an agent in your app? Just because I feel like agent has become a bit of a buzzword. It's kind of gone the way of Agile. And how the SDK works, not at a super deep level, but not super surface either. And then the first demo of the presentation will be fulfilling the title, the 10 minutes or less. So just starting from scratch, can we get something up and running with the Copilot SDK in 10 minutes? The second part here, application, will be a little bit more advanced, more realistic look at why use the SDK and more realistic advanced cases in our next demo, so which is the cooler demo. Half the reason of me giving this presentation is I get to show you my cool personal projects I've been working on, and I told them it would be educational, so they paid for me to come up here. And then finally, some considerations you will want for taking it actually to production, which we are not doing in this presentation. So things like authentication, stuff we're not going to cover, but you will want to think about when you deploy a real app. So for getting started, first off, what is the Copilot SDK? Who in here is currently using GitHub Copilot? Not SDK, just Copilot, either personal or dev. Okay. Who's going to keep using it after the pricing changes? Cool, awesome, okay. So Copilot SDK is pretty much what it sounds like. It's an open source SDK from GitHub to call GitHub Copilot from code. It says or other AI there because they support bring your own key. This is pretty much what it sounds like. You can bring an Anthropic API key, OpenAI. You can use local models. You don't even have to be logged into GitHub. And the Copilot SDK will still work with those. Officially, it's supported in TypeScript, Python, Go, C#, Rust, and Java. Unofficially, also Clojure and C++. This just means GitHub is not the one making those versions. It's some other person. Some third party is writing those, but they exist. We'll see this in our first demo, but very simple example, working example of what using the SDK looks like. So pretty simple. We just create a client here, a Copilot client. And then we call start async. That's what actually starts our Copilot process. Then we create a session on the client. I think this is a universal term now. It's not just Copilot. Claude Code calls them sessions too. A session is just a conversation. So when you open up a new conversation, you're opening up a session. So we're creating a new session here. This is where we choose some of the interesting properties, like which model we want. So here I'm doing Claude Sonnet 4.6. Our permission request handler. So it comes with one already made called approve all, and this is YOLO mode. So if you use approve all, it's equivalent to running Copilot in YOLO mode. And then finally, we actually send our prompt. So we don't send prompts on the client. The client has a session, and then we send prompts on the session. So here we're saying just, hey, what's the weather? And you can, we'll see this in the demo as well. You can set some other properties on these objects here. So before I go any deeper into any of this, I want to level set. What do I mean by put an agent in your app? What is an agent? And why do I want that? Why do I want an agent in my app, or my app is an agent, whatever this means? There's a good chance 100% or close to 100% of the people in here are already using AI agents for work anyway. But what do I mean when I say agent? I just want to level set, because I feel like now it's, you ask 5 different people, get 6 different answers. So, okay, what's an agent? If anyone watched Scooby-Doo growing up, and they take the mask off the villain at the end, this is what I think of with an agent. So it doesn't matter how you slice it, it's all an LLM under the hood, one way or another. So you take the mask off an agent, it's still just an LLM. That's all we really are working with. And all an LLM can do is take text in and spit text out. It cannot do anything else. It can't browse the web, can't run bash tools. It's just text in and text out. So obviously, those are not the tools we use today, right? We have things much more sophisticated than that and can do a lot of stuff. So a very simple example of what that looks like, we send our prompt, it goes to the LLM, and it says, hey, before I do anything else, are they asking about a website? And whatever their question was. And if they are, I can't do that because I can only do text in and text out. I don't know anything about websites unless it's in my training data. So instead of looking at my training data, go to the site, get the content, then put the content back to the LLM and synthesize some kind of response from that. And then spit out the answer. And if they're not asking about a website, then whatever, just get the answer. So we've kind of done 2 things here. These are called tools. We've given our LLM access to a tool, which is how to do something. And we've told it when to use this tool and how to use it. So this was originally, I think in 2023, made by OpenAI as a standard. That is probably a little hard to see on the projector. I have it open in VS Code here. So this is the actual, I think it's not switching my screen over. That's okay. This is the actual web fetch JSON for Copilot CLI. So it has a name at the top and a description, which is really just another way of giving it an English prompt to Copilot. So it says, here's a description, fetches a URL from the internet, and returns the page as either Markdown or raw HTML. Use this to safely retrieve up-to-date information from HTML web pages. So just from that, it's just an English prompt that tells Copilot, here's how to use this new thing. And it also has some parameters in the JSON. So it's got the URL, and it says this is a string, and each parameter also has a description, so Copilot knows like how to fill those things out. And still not coming up. And it'll fill those things out. And in this case, the only one that's required is URL, which makes sense. We're fetching a web page. And then that gets delegated to the harness, which runs some actual code to fetch the web page, and then spits out some output back to the LLM, gives you your result. So the user doesn't care about this, right? It's a black box. They just see prompt goes in, answer comes out. But this is just a very simple case of one single tool. If you can imagine, our actual tools have 20, 50 plus tools available in their toolbox. And they say, here's all the descriptions of when you should be using them. Decide for yourself when to use them. Even though it's just an LLM under the hood still, now all of a sudden it's kind of changed to this thing that has some level of agency and decision making for itself. So this is what I mean when I say agent here. And summary, LLM, it's just an LLM under the hood, text in, text out, but we've given it these tools, which are just calling some arbitrary code under the hood, that give it these decision-making capabilities. So we tell it, here's your tools, here's when to use them, and here's how to use them with these parameters, right? And then finally, we let it iterate. So like, okay, you can call the web fetch tool, now you have the browser content. Are you done with the task, or do you need to do something else? So the agent is all that together, is the LLM plus the tools plus the looping. So, okay. Now the second thing is why would I want one of these in my app? Why would I want my app to be one? However you want to word that. So I put together this very simple diagram, and this is actually how literally every computer program works. In that you have an input, and then you have an action, and then you have output. So all I did was change some of the wording here to get across the idea we're doing some kind of creative analysis, probably with AI, right? That's the whole reason we use AI instead of just deterministic code. So as some examples to give you ideas of what you can do with the SDK and things like this, here's a few things we're actually trying at the place I'm currently consulting at. So one is, I think it'd be super cool whenever there's a production error, by the time I even hear about it, I'm even pinged, there's already a suggested fix as a pull request. So this would look something like, production error happens, some process gets kicked off, you go collect those logs, clone down the source code, the SDK suggests some kind of fix and then opens a PR for you. Routing support tickets, if you are support team for this, whenever you get a ticket, look at the info that's in that ticket, whatever's in there, judge the severity of it and which team it belongs to, and then route appropriately. And then daily brief. So this is the one we're currently trying to get really working at my place. So in our case, we're connecting Jira, 365 stuff, so Outlook and Teams messages, GitHub repos, and pull requests, what's currently out there, pulling all the current stuff from the past week or the past day, whatever we've missed, and just say, hey, give me the stuff I need to care about today, at least at a first glance. It's like, hey, all right, well, you told this person you'd review their pull request a couple days ago. You still haven't done that. Maybe look at that. This is your stuff in progress on your Jira board, things like that. So these are repeatable things. We want them to work the same way every time for the most part, but we want some AI analysis in there. So this is a perfect fit for the SDK. And that brings us right into the first coding demo here, which will be our 10-minute bit. And it doesn't seem to want to share anything except my PowerPoint. For some reason. It was working before. Try to stop my PowerPoint and restart it. Maybe it's taken over stuff. There we go. I'll take it. Okay. So we're just starting from here. I'll zoom in a bit. All we have is our Copilot client. Let's go ahead and start a timer. I'm going to hold myself accountable here. Start a timer. All we have is our Copilot client here. We're doing start async. This will actually spawn our Copilot CLI child process that we will talk to. And then we want to create a session from this. So I'll say session. And I do want to give this some properties, which is session config. We want to give it the model in here. That's probably one of the most interesting things we can do in here. We'll just do Claude, Sonnet, 4.6. Let me look at my cheat sheet, because I can never remember if this last one is a dash or a period. And it is a period. I believe if you're using the Anthropic API, that's actually a dash, so I can never get that straight. Okay. And we do want to set on the permission request handler in here. I'm just going to do YOLO mode for the sake of the demo. But if you wanted to do something simple or more interesting, it's just a Lambda. You need to return a permission decision, it's called. But if we want to do something interesting, we could say if request.kind, if this is bash, then deny it or something. So you can do some more restrictive things in your permission handler, and in production, you probably should not be using YOLO, but I'm not in production, so I'm going to do that. Okay, So there's our session, and then let's just go ahead and send a message. So there's two options here. There's send async and send and wait async. It's not obvious the difference between those just from the names, but the difference is send async will return as soon as Copilot has received the message. You won't have a response yet, but it's queued up. Send and wait will not return until you actually have a response. So that's what I want here. I'm just going to say, tell me the weather in San Antonio, which it may actually be able to get that. We'll find out. And I'm actually going to put a breakpoint here and then run that bad boy. Okay, so that was actually pretty quick for our Copilot process starting up already. So our response, oh, that's because it hadn't run yet. That makes sense. And let me put I forgot to put my console write line in there. I believe it is in data content. We'll do that. I'll put my breakpoint here, because I do want to have us inspect that response object when he comes in. Okay, so let's look at the content here. And yeah, I'm a software engineering assistant and don't have access to weather data or APIs, which is correct. So some of the other stuff we have on this response object is, if we go in data, it's always inside data. So we have the model it was called with, the message ID. We have the reasoning. So the user is asking about the weather in San Antonio. I'm a CLI tool, blah, blah, blah. Not all models have reasoning, but if they do, you will see it in there. How many tokens, how many output tokens were used up? Tool requests, which wasn't any. So maybe some useful things in there if you are monitoring. Let's do something a little bit more interesting. You can react to all kinds of events that go on in the SDK using this .on event on the session, or method on the session. And this is, again, just a Lambda, and you can do whatever you want in here, really. And there are a lot of different kinds of events. So here are all the different ones. So you can see it's pretty granular. So it gives you an event just when it has a different intent, when it gives you a message, some MCP events, hook events, when the session started, when the session goes idle. It's very granular, so you can react to just really anything you want. So I'm going to illustrate streaming here. So I'm going to react to, I'm going to say if session event is, I believe it is assistant message delta event. And we're just going to console write line with a few underscores so we can tell what the delta event was, and I'll explain that in a moment. Delta content, I'll put 3 underscores there. I think I used the wrong type here, which is assistant message delta event, which is correct. I used the wrong. It was a very closely named one, I suppose. There we go. So if you have used AI assistants at all, streaming responses are what you are used to, most certainly. And we can set that here. What that means is you will get the response in chunks instead of all at once. So you'll get them probably around like 5 characters at a time or so. You'll see it stream in as Copilot creates the response. So depending on what type of app you're creating, you may or may not care about this. If it's user-facing, you probably do want streaming responses. And just to show you how many streaming events we get, I put that in there. But okay. We have 3 minutes left on our 10-minute timer, but I'm pretty happy where we were already with this first response anyway, because that's already the SDK working. But let's see what our streaming events give us. So here is I should have done a blank right line in between, but here's the whole response without the delta events. And I separated each delta event with these 3 underscores. So you can see each chunk is pretty small. I'm a software is one chunk, engineering assistant and is another chunk. So pretty small streaming events. Let's just leave it as streaming. The last thing I want to do is create a custom tool, and I'm just going to copy paste for that just in the interest of time. And this will be a fake tool to get the weather. We're not actually going to reach out to anything and get the weather. You can see here, this tool is just a normal C# function. There's nothing weird about it, except it has these attributes on it. So to show you what this is doing, this is called get weather. We're turning this thing called weather data, which is just a record I've made with 2 things, integer temperature and string condition. That's it. So, and we're just returning a fake one. We're not actually reaching out and getting the weather. So we return that it's 100 degrees and it's too dang hot for this time of year. That is usually the answer you will get in San Antonio if you ask people what the weather's like. And you'll see, similar to the tool JSON I showed, this description tells Copilot how to use this tool. So it says gets the current weather information in the requested city. And I have one parameter, which is the city name, and this also has a description, which is the name of the city to get the weather for. Now, under the hood, this is turned into that JSON for us, so we don't have to write any of that. All we have to do is decorate our stuff with these attributes. You cannot have spaces in your tool display names, so that's why this underscore is here. And the way we add this to our, to let Copilot access this, is there is a tools property on our session, and then it's an array, and then in the Microsoft Extensions AI namespace, there's this really handy function, AI function factory.create, and then you just give it your C# function, and then that does all the magic for you, basically. It handles turning it into something that Copilot actually knows how to call. Something that's really cool, you can even put breakpoints in these, and it'll hit them whenever Copilot calls them. So we can see for sure if Copilot will call it here. It's pretty good odds because we're asking something very simple, but there's always the chance, AI is non-deterministic, that it hiccups. So it is hitting it, and we see it's passing in the city name of San Antonio, right? We did not tell it to do that anywhere in the code. Copilot figured that out for itself because the initial prompt was this one here, tell me the weather in San Antonio. So it's going to return this fake weather data. That's going to go back to Copilot, and then it's going to synthesize us its response, which will be taking a sweet time here too. There it goes. So here's the current weather information, 100 degrees Fahrenheit. It's too dang hot. Stay hydrated. So cool. I've seen these question marks a few times. I think this must be like an encoding issue in the console, and it's an emoji or something. I'm not sure. But okay, so I'm happy with that. This is our very basic Copilot SDK demo. I mean, these are the bones. I mean, this is basically it right here. Any of the customization stuff is going to be in your session config here. So some of the other thing, you can say which agent you want to use. So if you want it to be an autopilot, things like that. Excluded tools, you say you are not allowed to use these tools. Tell it what hooks you want it to use. MCP servers. Skills, we'll see in the other demo. I'm actually giving it some custom skills as well. Some more interesting stuff. The Copilot client also takes some Copilot client options, is what they call it. We did not care about any of this stuff for this demo. But if you wanted to give it like an Anthropic API key, something like that, or if you want to change the current working directory, you can do that from here. In my experience, most of the stuff is going to be in the session. And actually, now that I say that, I believe API key is also in the session, actually. But we'll see that in the second demo. So I'm going to say I did extra, because our first thing was just can we get the SDK working? So I'm going to give myself a pass on did I hit 10 minutes. So good job, me. Very impressive. All right. Back to our presentation here. I sort of hinted at this in the demo, but the SDK really doesn't do anything magic to hit Copilot. It just uses the Copilot CLI. So one way or another, it's going to hit the CLI. Okay, so this is it. This is how it works. It uses JSON RPC to talk from your code to the CLI. And there are a few options for how it hits that CLI. So by default, for C#, it does not use the CLI that's on my machine. It actually has its own process that's bundled with the app. So this has some pros and cons. The pro is that I don't have to worry about, if I'm on like the super latest version of the CLI, the SDK probably won't have feature parity with that yet, so I don't have to worry about that. I also don't have to worry about pushing out, if I'm deploying this somewhere, I don't have to worry about the CLI being on that machine because it's bundled with my app. But for these other languages, Go, Java, and Rust, it does use the CLI installed on the host machine. So this has some advantages as well. So if you're going to have multiple instances of this app running, so if you have a lot of tenants maybe, then you probably just want one CLI process. You can also run the CLI process on a remote server and then give it a URL to hit. So we're not going to do that in the demo, but one way or another, it doesn't matter how you slice it, it needs to hit a CLI process, Copilot CLI. So feature parity with Copilot CLI. SDK really has everything the Copilot CLI has. Really, all the SDK is a way to surface all the CLI features in code. So there are a handful of things it does not have, either because the protocol doesn't support it. Like I think /share is one thing it does not have, which is something you can do to like export your session history to Markdown. You cannot do that because the protocol doesn't support it. And there are some things that just doesn't make sense to do in the SDK, like changing the color of the terminal, stuff like that. It doesn't support because you're not in a terminal. You have no UI, things like that. And then authentication. So by default, this is going to use your signed in CLI user on your machine. And this is what it did when I ran it. And it successfully hit Copilot. It's because I'm using my personal Copilot plan. You can also use GitHub OAuth and a token in your environment variables, or like I said, bring your own key. So this is a really cool option because you don't even need to be logged in with GitHub to do this. GitHub's not involved at all in this case. So you can use a local model. You can use an Anthropic or Azure Foundry or OpenAI API key, and you are not interacting with GitHub at all. You're basically just taking advantage of the Copilot harness. And if you're already familiar with Copilot and its API surface, you can take advantage of that for the SDK, and it still works the same. And we already went over tool calling, but I wanted to call it out again because I feel like this is one of the things that really makes it stand out, makes it special. So, and this is just the one we did. But again, yeah, I just wanted to call out, it's just C# functions or whatever language you're in. You can do whatever you want in here and then tell Copilot how to use it, and it'll be able to use it as a tool. So this is a question I want to address because this is a question I had when I first started using the SDK. So like, can't I just do this stuff with prompts? Why do I need code for this? So has anyone used stuff like GitHub Spec Kit or BMAD, stuff like that? Okay, so these are a little sophisticated developer libraries, and they work by just chaining a bunch of prompts together, basically, getting the output from this prompt and giving it to another prompt and working until you get to the end. So the workflows are just a little different. And let me illustrate this by saying you can trust AI, but only a little. So here's an example of just a prompt workflow. And these are example numbers. I don't know what the actual success rate would be. Probably depends on the task you're doing. But if you're just passing data from one prompt to another prompt to another prompt, if we say each one of those has like a 90% success rate, what do you think? Are there any math people in the audience? What do you think the total end success rate you will end up with? Who thinks it's above 50%? Thinks it's above 60%? 70%? Okay. No one should have their hand up for 90%, by the way. The end result is 59%. So the reason is these failures compound on each other, right? So if you're flipping a coin twice and you never want to get tails, you have a 25% of that happening, 25% chance of that happening, right? So in each of these, if we have a 10% chance to fail on each one of these, it ends up being a 59% success rate overall. If this is something we want to automate and happen generally the same every time, right? Maybe the creative analysis part is different, but if we want this thing to be reliable, like our daily brief or whatever, then you're just taking more risk by prompt chaining. So by contrast, if we use the SDK and use deterministic code for everything except where we actually want the AI to do its creative stuff, this is just 90% success rate. It's whatever the lowest part is, because everything else is 100%. So our lowest part is wherever AI is, which is 90%. Again, made up number. But driving home the point, code is always going to be more reliable than AI. It doesn't matter what you're doing. AI is non-deterministic. The reason we use AI is because it can do creative stuff, right? Code cannot do that. So another big win, code is way cheaper overall. It's not even close, especially with the way tokens are going now. AI is always going to be more expensive. I think a possible pro for the prompt workflow, it is super easy to POC stuff with this, or like prototype stuff with this, right? So I'll say that's an advantage there. But I think if you're wanting to set up something repeatable to happen overall, like keep happening in the future, using the SDK is what you want to go with here. These brackets are supposed to signify, it kind of puts guardrails around your AI. There's no good emoji or anything for guardrails or like a fence or anything. So I just did brackets. But it kind of puts guardrails around whatever your AI is doing, because whatever the output from the AI just gets passed into actual code, not another AI. Okay, let's use some more examples to illustrate this. So just pair programming or doing a code review. Who thinks this is a better fit for prompting only? Who thinks this is a better fit for SDK? And this was an easy one, not a trick question. Obviously, this is better for prompting. There's no point writing an app, that can help you pair program. Every problem is going to be different. You can't predict that ahead of time. Kind of what I mentioned before, reviewing some work before stand-up or refinement or something for a summary. Who thinks better for prompting? And better SDK? Yeah, so I'm going to say SDK. I think this one could maybe go either way. It's probably a bit of a spectrum where it could fall on. I think SDK is a good fit for this one because you have some deterministic parts, like I'm calling the Jira API or I'm calling the GitHub API that I want to know for sure are going to work the same every time and feed data into my analysis. Brainstorming app ideas, I count this almost the same as pair programming and code review. This is a wholly creative process, right? It's going to be different every time. We can't predict it ahead of time. So I don't know if it would be possible to write an app for this. And in-app recommendations, this would be something like, I'm going to look at the user's order history and their current activity. Maybe I want to avoid churn rate, something like that, so I can surface some recommendations to them. This would be an excellent use case for the SDK because we want it to run on a certain event or a certain schedule. And we have some creative analysis in there, but we want to get stuff out of a database or hit an API for this, right? And we want to know for sure that's going to happen deterministically. So this is one of the things I mentioned earlier with getting AI to, like, whenever a production error happens, by the time I hear about it, I want to see a fix already in a pull request. So this would be an example of how to split this work out, right? So a prod error happens, Copilot, and it kicks off some process. Copilot SDK sees that and it says, okay, based on that log, I'm going to choose some additional filters that maybe these would be some good additional logs to bring in to see those stack traces, to see the flow of data, how that happened. So searching the logs themselves does not need to be an AI task, right? That's deterministic. So we let code handle that. Maybe that's code in your tool call, right? And then we have Copilot do its creative stuff. We analyze all those logs that came back, all the stack traces. We use git CLI to just clone the repo and create a draft PR for us. And then Copilot does its thing. It says based on the stack traces, and I clone the repo down. I'm looking at where those things are. Here's what I think the fix is going to be. So it creates a branch for that and puts its fix in there. And then however you notify your team, that gets kicked off. And this whole process could happen, I'm sure, easily in 30 minutes or less, depending on what model you're using. And I think this would be, I've yet to get this to happen, but I think this would be a super cool use case. I'll say, in my experience, the hard part of making this happen is not the SDK. The SDK is super simple to work with, and developers typically know what problems they need to solve already. The problem is governance. So it's like, can I get access? Am I allowed to give Copilot access to the Jira API, or am I allowed to give it access to make pull requests for me? Especially in big enterprises, that's the part that's going to be more difficult to get through. Okay, so the cooler demo. This is the part where it's kind of an excuse for me to show you some of the cool things I've been working on. And for you, it is to see a more sort of realistic example of what these things might look like in practice. So first one, let's open up. I have a few to go through. Let's open up this one. And it's not switching again. PowerPoint's just like dominating my computer. I have to close it and then, okay. Okay, so I'm going to go ahead and run it first and then show you the code, just because I think that'll be more fun. So this is, use a Copilot SDK kind of to make my own crappy version of OpenClaw. So it does actually work with Telegram. I believe it's running now. Okay, it's up. So I named my bot Shodan. Does anyone understand this reference? No? Okay, System Shock 2. Okay. It's the evil AI robot. So we'll see what kind of decision that was to name my AI that, but let's just give it, I'm going to use it from my phone because I think that would make for a cooler demo. And I did give it the ability to process images, so I'm going to send it a picture of me with my kid there and just say, hey, what do you think of this? So you can see in the background in my terminal, something's happening here. And it says, oh, what an adorable photo, a smiling dad and a very happy chubby-cheeked baby. Okay, so downside of this is, I guess, Microsoft now has a picture of my baby and their training data, but that's how it goes, I guess. So this was not very hard to do, to be honest. So let me show you. I'm going to stop this here. Actually, let's ask it one more thing. I'll just go through here. I'll say, what GitHub repos do I have? And is there anything in my notes relevant to any of them? And I'll show you what all that means in a second here. So when it's getting Copilot's response, this is just hitting Copilot CLI on this same machine, and then when it gets the output, that gets forwarded to the Telegram SDK I have in this project, and it puts it in a new chat message. So it says, hey, here's your last 20 repos, and this is correct. These are my repos from GitHub. And it says, your only note is a reminder to do the dishes, and that's correct. So I'm going to stop this here just to make it a little bit easier to show the code. So what we probably care about here is the Copilot folder, and I put it in this Copilot service. So I'm doing a little bit more in my session configure. I am setting the model. I like to rename my session IDs. I prefix them with Copilot Assistant and then a GUID, just so I know if I'm ever going back and looking at my sessions later, I know this was like made from the app, something I didn't do myself. I give it some skill directories here, or a skill directory. And this is this agent skills. And I did it, these are from Anthropic. If you can't see these, they're docx, PDF, PPTX, and XLSX. Just so it knows how to work with these files. It can do stuff with Word and Excel. It can read those documents and edit them. So if I uploaded a Word document from my phone, it would be able to manipulate that. And I give it some custom tools here as well. And these are all in the tools folder. There's only two. One is the notes tool. All this is there's a local file on my computer that's a markdown file. And whenever I ask it to take notes, it just puts stuff in that markdown file. And whenever I ask it about notes, it takes stuff from it. So last week I put something in there about washing the dishes, and that's what it's taking from. And then I have a GitHub tool, which is using the OctoKit SDK that GitHub provides. And if we want to look at one of them. So here's one that's for listing and getting my repositories, which what we just did. And you can see the descriptions on the properties here are like repository owner, repository name, and when they're required. So they're nullable in the code. But sometimes, depending on what it's asking for, the GitHub API does require those things. So Copilot needs to know about it. The notes tool is extremely simple. It's just markdown text to append, required when the operation is append, and then the operation, which is either read or append. That's the whole thing. So the rest of this app is mostly like integrating Telegram with it, which is kind of a separate part from the Copilot SDK itself, right? Editing a message that Telegram is sending me or doing a new message. So this is my latest project. To be honest, part of the reason I'm going to go through a couple more. Part of the reason I have all these projects is because I was trying to find a way to burn through all my premium requests before we lost premium requests. So I said, it's only going to last so much longer that a GPT 5.5 only cost me 7.5 premium requests. And that day has come. Okay. So recipe book. This is another one I have. I have a lot of recipes that I use over and over from online websites and stuff, but if you have ever looked up recipes on websites, you know that it's very annoying. So I had a thought is, what if I could just give it a URL, and then Copilot looks at the web page, and it finds on the page where it scrolls through all the useless stuff I don't care about, where is the actual steps and the ingredients, save that for me in a markdown file, and then I never have to go there again. So that's one. And then same thing with a YouTube link, but this uses FFmpeg and Whisper to download the YouTube video, get the transcript, and then do the same thing from that. So what that looks like, I'm not going to do it right now because it'll take a little bit, but what that looks like when something is saved is, pretty simple. Here's the ingredients, here's the steps, and these are just markdown files on my computer, so I could go and edit them myself if I wanted. Really, the cool part is how it gets into the markdown file. So I'm going to stop this as well, and it's going to look very similar. If I go to Copilot service, the same abstraction I used before, you can see here, I pass in the model, which is from app settings. I don't even know what I'm using for this. It is, I think I'm looking at the wrong app settings. That's okay. I think it's Claude Sonnet. I did the same thing where I'm appending to my session ID. I am doing approve all here. And here I'm also editing the system prompt. So you have two options when you do that. You can append to it, or you can just erase it completely and give it a new one. So I guess here I give it empty string, but in the previous one I told it like, this is what you're designed to do, structure your responses in this way, in this certain JSON, and then I'll parse that JSON. And then I even abstract send message out, so the callers can just use Copilot service and use whatever message options I have pre-made. So here it's just prompt, but I could do something more complicated here if I felt inclined. And let me point out something in this Copilot Assistant, because I believe this one was actually using bring your own key. So if I go to app settings, yeah, it is. So I have this use Anthropic provider setting, which is true. My Anthropic API key is not near because it's in a .NET secret, because that would not be wise for a presentation that's going on YouTube. And I'm telling it use Claude Sonnet. And then in my Copilot service, all it is an if statement. It says, hey, if use Anthropic provider is true, then replace the model, use the one there instead. And there's a provider property on session config that you make this provider config object. So I'd say it type is Anthropic. Base URL is always this for when you're using the Anthropic provider. And then I give it my API key. And that's it. So we already saw this work with Telegram. So in this case, when you saw that working, it was not hitting the GitHub servers at all. It was using the Anthropic API under the hood. So, and it kind of just works. So it's cool that you can swap out stuff just that easily and quickly with the Copilot SDK. Okay. Where am I on time? Okay, I'm doing good. Let's go to this one here. I think this is a cool little example of what you can do under the hood with the SDK. So if anyone knows what a mind map is, it's just kind of a way to brainstorm things. So if I go to one that exists here already, so you kind of start with one idea, and then from that you branch ideas off of that idea, and you can continue doing that. So I think I have some things. Yeah, help me plan a vacation. That's a good one. So for vacation planning, you might do packing and preparation, travel and accommodation, itinerary and activities, budget and expenses. These are things that are related to vacation planning. So what I did for this one, this is using Copilot under the Copilot SDK under the hood. By each one of these nodes is actually a separate Copilot session. And the way it works is the child sessions are forked from the parent session. Copilot has this concept of forking. So when you fork a session, it clones that session, including the session history. So the intended use for this is you can try different strategies in your sessions and keep your session history. You don't have to retell it the same thing over again. In this case, I used it to clone the session history into the child nodes. So this one, it started out with help me plan a vacation, and Copilot responded, here's a mind map to help you plan your vacation. And then you can see it got forked. This is a child node now. So it says, hey, packing and preparation was forked from vacation planning. And I said, give me some more info. And it was like, all right. And the way it did that was it gave me some more branch ideas here over in the right pane. And I can either, I can say, yeah, I don't want these two, or I want all of them. And when I click on create branches, it will fork even more sessions. So now it's forked off of here. So off of packing and preparation, it's got home arrangements, weather and preparation, travel documents. And I can even click on this open and CLI button, and it'll actually use the CLI process on my machine to open that session up. And you can kind of see under the covers here what my prompts are. And it's kind of requesting Copilot to do this JSON responses. It's not, I don't know if I'm able to zoom in on the CLI here. There we go. It's not just prompts and responses. So under the hood, my system prompt to Copilot is like, hey, this is what your job is in this app. You create nodes. Whenever you reply, you need to structure your response as a JSON array with the suggested nodes. So that's what this is here. So here's the normal reply that goes in the chat window. Here's the branch suggestions it gave to me, and each one has a title and rationale. And here's what you see in the mind map. You see packing checklist, travel documents, weather preparation. And then under the hood, the user messages also get changed as well. So the user message was just give me some more info, but in here I kind of injected more stuff into the user message. It says your entire response must be this single JSON object. Do not include anything else. Like super telling it, hey, don't screw this up. And telling it this is the shape its response needs to be. So I can continue chatting in here in the actual CLI if I want to. And then let's go ahead and stop this here. So same idea. If we go out to Copilot service, you can see I've got some fork methods here now. Because of the functionality of this app, I need to fork stuff. And create system message is where some of that magic happens, where I tell it how to construct its responses with JSON. So if you wanted to do fork in the actual Copilot CLI, it's just /fork, by the way. So the way that's surfaced in the SDK is .rpc.sessions.forkasync. And there's a lot of other things in this RPC object. This is how you tell it to change the model it's using. You can just do a ping on it, change the account or get the account APIs to get your quota. But a lot of things that are built into the Copilot CLI end up being serviced on this RPC object. So the idea of showing you these, just kind of get your ideas flowing of what's possible with the SDK and just how easy it is to get started with this. Okay, so let's finish up, not with Godot, with the end of the slides here. So like I said, when you actually are deploying this to production, there's a few things you want to think about. Probably number one being sandboxing. You probably don't want to be running this in YOLO mode when you're actually in production. So that means running it in Docker or doing something to limit what it has access to. Maybe putting it on a separate VM or something altogether, right? So user experience considerations, if this is a user-facing app, so like streaming responses, like I said, maybe displaying to the user that Copilot is doing work because you can have long wait times with AI. And then you really want to log everything. So the session events make this easy. Whenever a session event happens, you can log it. Copilot SDK supports OpenTelemetry out of the box. You can give it a file to log to. You can give it a URL to send its spans and things to for OpenTelemetry. However you do this, there's kind of these three stages you want to address. First is authentication. Figure out how you're going to do that. Am I just going to use the logged in CLI user? Am I bringing my own key? Am I using GitHub OAuth? Or am I like putting a token in my environment variable somewhere? Which CLI am I using? Am I just using the one that's bundled with the app? Everything I showed is the one that's bundled with the SDK. Do I want to use one that's local to the machine? Or do I want to use an external one on a remote server somewhere? And then what do the users of my app look like? Do I only have one user? Is it just me, right? Do I have shared user, like a single CLI process that multiple people are sharing? There might be security concerns there. Do I have one CLI process per user? So these are all valid. It's just depending on your use case, which one of these do you want to use for your app? And so that pretty much does it. As a recap, we went over what an agent is. Why do I want to use an agent? We went over how it's just the LLM with tools, and we give it a loop to go over to make sure it does the task, right? The Scooby-Doo mask, how when you get down to it, it's just the LLM, text in and text out. So saw some things you can do with the SDK, how it just calls down to the CLI one way or another, right? We went over some of the features it does, our 2 coding demos, and then why you might want to use SDK over just prompting, right? And then like we just saw, the prod considerations. And if you are interested in getting started with this, honestly, just the GitHub repo, Copilot SDK, is an awesome starting point. They have awesome docs on there. They have awesome code snippets. And then the awesome Copilot GitHub repo, both of these repos are from GitHub. They have a cookbook section on this repo specifically for the Copilot SDK, also with some great code snippets. Almost everything I've learned how to do with the SDK has either been from these or asking Copilot itself. So that's it. Thank you. I believe, I'm trying to remember now, I think it's the one on the left will take you to my LinkedIn. The one on the right is for the slides for this presentation, if you are interested in those. So I believe we're pretty much at time, but if anyone has questions, I will be up here for a few minutes. Yes? Do we have a microphone? No, to mess with local files, is that what you said?
Like, if the user prompts it to like delete the local files, like if deploy the production and some user just asks to delete local files or show the API.
Like, show me what, yeah. I mean, that could happen. So that would be something you need to do hooks or the permission handler to not let that happen, like to block that, to limit what Copilot has access to. Because people are going to try to, if it's user-facing and it's an AI tool, people are going to try to manipulate it. That's, yeah. I mean, you can still obscure the API key in some way such that the process doesn't even know ultimately what it is. Right? The question was, how do you obscure? So basically, like if it's front-facing and the user asks, like, hey, what's your API key? How do you handle that, basically? So, yeah. Any other questions? Okay, thank you. And I'll be up here for a few minutes in case anyone wants to come up here and ask something. But, yeah, good. Thank you.